the full story of our search for aliens. Introduction: the cosmic question. For as long as humans have gazed at the night sky, we have asked a trembling question: are we alone? NASA notes that since the beginning of civilization, humanity has wondered whether we are alone in the universe. Imagine standing in a dark radio observatory late at night. The humming machines and blinking lights are your companions as you listen to the cosmic static. Suddenly, amid the white noise, a blip appears, strong, strange, and fleeting. In August 1977, Ohio State University astronomer Jerry Eman encountered just such a signal. As the story goes, he looked at the printout of a narrowband radio spike lasting just 1 minute and scrawled in excitement, "Wow!" That unexplained signal followed the telescope's beam shape as the Earth rotated, suggesting it came from far beyond our world, but it never reappeared. The "wow" signal remains one of the most tantalizing hints ever recorded, a cosmic whisper that still stirs our imaginations. This is exactly the drama and mystery at the heart of our story. Every discovery and every false alarm fuels our excitement. NASA scientists tell us that we now have technology powerful enough to finally probe these ancient questions. As we will see, decades of exploration have built a foundation to answer a fundamental question: are we alone? In this documentary, we embark on a journey through history and cutting-edge science. From the earliest searches with radio telescopes, to daring missions that scour Mars, Titan, and beyond, to a new era of thousands of worlds orbiting distant stars. Along the way, we will follow the clues, the setbacks, and the people who have dared to listen to the cosmos. The dawn of SETI, listening to the stars. In 1959 to 1960, two events launched the modern search for extraterrestrial intelligence, ST. That year, physicists Giuseppe Cacconi and Philip Morrison published a paper suggesting we could detect aliens by tuning radio telescopes to pick up their signals. At almost the same moment, astronomer Frank Drake at Cornell University tried it. Drake used a 26-meter dish at Green Bank, West Virginia, to listen for radio broadcasts from two nearby sun-like stars, Tau Ceti and Epsilon Eridani. He called the experiment Project Ozma, after the Princess of Oz, dreaming that alien life might be reaching out just as we have unknowingly beamed our own TV and radio signals into space. On a chilly spring morning in April 1960, Drake climbed the telescope and began one of history's first SETI scans. For 3 months, it observed those stars, but found nothing more than cosmic static. "The stars were stubbornly quiet," he later said. Drake was disappointed, but he didn't give up. In fact, he turned his disappointment into inspiration. In 1961, he drafted the famous Drake equation, a way to estimate how many intelligent civilizations might exist in our galaxy. The equation multiplies factors like the number of stars, the fraction with planets, those with life, those that develop technology, and so on. It's still used today to frame the problem. Early on, Drake and his colleagues realized that we only knew one example of life Earth, so the numbers were guesswork. But each discovery that a star has planets, or that life can survive in harsh environments, changes those estimates. Remarkably, modern data have started to fill in some blanks. Jason Wright, an astrophysicist at Penn State, explains that when Drake wrote his equation, we didn't even know if other stars had planets. Now we do. He notes that about 1 in 4 sun-like stars have a rocky planet in the Goldilocks zone where liquid water could exist. In other words, with hundreds of billions of stars in our galaxy, there may be tens of billions of worlds that could be habitable. The implications shook the astronomical world. It suggests the Milky Way is teeming with Earth-like planets, vastly increasing the odds that life could be out there. NASA enters the search. While Drake's work launched SETI in academia, NASA soon took interest as well. In the late 1960s and early 1970s, the agency quietly funded various SETI-related projects. For example, in 1971, NASA's Ames Research Center proposed an ambitious plan called Project Cyclops, a vast array of 1,000 large radio dishes that could pinpoint alien signals from far across the galaxy. It was called a billions-dollar system for SETI. Ultimately, Cyclops remained on paper due to cost, but it showed NASA was thinking big. By the 1980s, NASA's support had grown more formal. In Washington, NASA headquarters began considering a dedicated SETI effort. In 1988, they officially endorsed the idea and announced a high-resolution microwave survey to scour the sky for artificial radio signals. Symbolically, the program kicked off on Columbus Day in 1992, 500 years after Columbus set sail, as if heralding a new age of exploration. But before long, politics intervened. In late 1992, soon after the SETI program started, US Congress pulled the plug and canceled funding. NASA's direct SETI work abruptly halted less than a year after it began. After that setback, NASA shifted focus to related questions, the origins of life and habitability. Since then, NASA historian Mikola Ostovar notes, NASA's efforts have been directed towards furthering our fundamental understanding of life itself, its origins, and the habitability of other bodies in our solar system and galaxy. In practice, this meant investing in astrobiology, the study of how life begins and where it might thrive, which helped point us to the most promising places to look. At the same time, private and nonprofit groups kept the seedy flame alive. The setback only pushed the search into new hands. Philanthropist Paul Allen funded the SETI Institute and the Allen Telescope Array, and grassroots projects like the SETI League mobilized amateur radio astronomers. As one NASA article puts it, after the cancellation, part of the program was picked up by the private, nonprofit SETI Institute. So today there are constant sky surveys searching for techno-signatures, not just radio beacons, but any signs of technology like laser flashes or megastructures, even if the government isn't footing the entire bill. Searching our backyard, life on Mars and beyond. Meanwhile, NASA turned its exploration robots and telescopes toward our own celestial neighborhood, looking for any hint of life. The logic was simple: if intelligent life exists, maybe simpler life exists closer to home. Mars became the prime target. In 1976, NASA's Viking 1 and 2 landers became the first spacecraft to look for life on another planet. They carried microscopes and chemical labs to analyze Martian soil. Viking detected curious chemical reactions, enough to raise eyebrows, but ultimately found no undeniable sign of living microbes. Still, even that ambiguous result was a huge milestone. It was the first time we treated another planet as a biosphere to investigate. Over the decades, a succession of missions painted a richer picture of Mars. The twin rovers Spirit and Opportunity, which landed in 2004, confirmed that liquid water once flowed on the red planet. They discovered ancient streambeds and minerals that form only in water. We now know Mars had lakes and possibly a warm, wet climate billions of years ago. Curiosity, the car-sized rover launched in 2011, found that Gale Crater once held deep freshwater lakes with all the chemical ingredients for life. Every finding tells us that early Mars had habitable conditions, long-lasting liquid water, and energy sources that could sustain microbes. Beyond Mars, NASA's probes have peered into the outer solar system, where oceans hide under icy crusts. The Galileo spacecraft orbiting Jupiter in the 1990s discovered that Europa, a moon of Jupiter, hides a global ocean beneath its shell of ice. Even more dramatically, the Cassini spacecraft at Saturn in the 2000s revealed worlds we never dreamed of. Titan, Saturn's giant moon, has lakes and seas, not of water, but of liquid methane and ethane, a totally alien kind of ocean. Astrobiologists study Titan as an Earth's cousin, where complex chemistry is happening in a frigid environment, giving clues to pre-life chemistry. Cassini also flew through geysers of water ice erupting from Enceladus, a tiny moon of Saturn, and detected saltwater and organic molecules. The presence of a subsurface ocean on Enceladus, complete with energy and building blocks, instantly made it one of the most exciting places to look for life. As NASA put it, these discoveries expanded our understanding of the kinds of worlds where life might exist. All of these missions, to Mars and the icy moons, were not originally for SETI. They were traditional planetary science. Yet each one informs the search for life by showing where habitable environments occur, and by teaching us what signs of life might look like. Astrobiology research here on Earth complements this. Scientists have found microbes thriving in boiling hot vents, Antarctic ice, acidic lakes, and deep underground. Life, we've learned, is stubborn. It adapts to extreme conditions we once thought sterile. If life could evolve on Earth under such extremes, perhaps it could arise on Mars 3 billion years ago or beneath Europa's ice. A universe of worlds. The exoplanet revolution. While robots scoured our solar system, telescopes changed our view of the galaxy. In 1995, astronomers discovered the first true exoplanet orbiting a sun-like star. That was the start of a revolution. NASA's Kepler Space Telescope, launched in 2009, was designed to find Earth-sized planets by watching thousands of stars for tiny dips in brightness as planets crossed in front of transit. After 9 years of observing, Kepler delivered a staggering legacy. It found over 2,600 confirmed exoplanets and showed that our sky is filled with billions of hidden planets. In fact, Kepler demonstrated a deep truth. There are more planets than stars in the Milky Way. Where once we thought planets might be rare, now we know they are the rule. Artists' concept of a kaleidoscopic array of exoplanets discovered beyond our solar system. Each colored sphere represents a world found by NASA's planet hunting missions. Today, NASA reports the tally of confirmed exoplanets has surpassed 6,000. And that number keeps growing with new missions. There are thousands more candidates awaiting confirmation, thousands of distant worlds of all kinds, scorched lava, planets, gas giants the size of Jupiter, fluffy sub-Neptunes, and many rocky Earth-like worlds. Some of these orbit in their star's habitable zone, where temperatures could allow liquid water on the surface. In some cases, we can even probe their atmospheres. The Hubble and Spitzer space telescopes, for example, have measured the ingredients of exoplanet atmospheres, detecting water vapor, methane, and more. These are the first steps toward finding biosignatures like oxygen or organic gases in alien skies. As Sean Donegal-Goldman of NASA puts it, each of these discoveries brings us closer to answering the age-old question, are we alone? The flood of known exoplanets changed the way humanity views the night sky. No longer are we a lone oasis. We see hints that life might have many other gardens. Yet the silence remains. Every planet we find leads us to listen even more closely. In the next part of our journey, we will explore the cutting edge of this search, how new telescopes and ingenious methods are hunting for the faintest glimmers of life, and how a single discovery could rewrite our place in the cosmos. For now, we stand on the threshold. The astronomical world has opened up, and the quest continues. Sources, all facts above, are drawn from authoritative sources, including NASA and peer-reviewed publications. Key references include NASA history summaries of SETI, NASA astrobiology articles on missions, and official NASA news releases on exoplanets, as well as science journalism accounts. The quotes and figures have been paraphrased for narrative flow. Each paragraph is supported by connected sources as shown. The full story of our search for aliens. Part 2 continued. Missions on the horizon. By the 2020s, humanity has found thousands of worlds beyond our solar system, but it's only been sending probes and rovers through our own planetary backyard for a few decades. Now, the next wave of bold missions is already on the launch pads and drawing boards. Soon, we will be piloting robotic explorers to the most promising habitats in our cosmic neighborhood. For example, NASA's Europa Clipper, launched in 2024, will spend years with its 9 instruments secretly whispering and listening to Jupiter's icy moon. It will swoop in close nearly 50 times, skimming just above Europa's crust and beaming radar pulses to probe the hidden ocean below. Scientists suspect that beneath that cracked ice lies more water than all of Earth's oceans combined. Clipper will analyze the vapor plumes and the chemistry of Europa's surface, testing whether those dark waters have the salts, organics, and energy that could sustain life. Mars looms as another prize in this cosmic tour. Our Perseverance rover is already catching golf ball-sized rock samples in sealed tubes, selected from what was once a Martian lakebed. The plan to bring them home is nothing short of epic, and several rockets and spacecraft will work together to launch those samples into Mars orbit. Then an orbiter will catch them and return them to Earth in the 2030s. When those Martian rocks finally arrive in Earth laboratories, scientists will pry open vials of dirt from another planet and reveal Mars' story in exquisite detail. And other nations have joined the race. China's Tianwen-3 mission, slated for launch in 2028, intends to drill and collect at least a half kilogram of Mars soil and return it to Earth by around 2031, potentially beating the American-led campaign. Meanwhile, Europe's ExoMars program will send its Rosalind Franklin rover in the late 2020s to drill 2 meters into the Martian soil, looking for any preserved traces of life. Even farther out, NASA is preparing Dragonfly, a revolutionary rotorcraft mission to Titan, Saturn's largest moon. Dragonfly will launch in the mid-2027, arrive by the early 2030s. It's an octocopter drone designed to fly in Titan's dense nitrogen atmosphere, hopping between dune fields and methane lakes. Titan is an organic chemist's dream, a frozen laboratory filled with carbon-rich molecules. Dragonfly will fly multiple sorties to dozens of locations, sampling the complex organics in the environment and searching for any signs of past or present life. In effect, Dragonfly will be the first mission to truly explore the building blocks of life on another world. Europe's space agency has its own grand plan. The JUICE mission Jupiter Icy Moons Explorer launched in 2023 and will arrive at Jupiter in 2031. JUICE will orbit Jupiter and take repeated close passes of Ganymede, Callisto, and Europa. Carrying powerful instruments from NASA and Europe, JUICE will map the ice thickness and probe the subsurface oceans of these moons. Along with Clipper and Dragonfly, these missions will survey all the major ocean worlds in our solar system. By the end of the 2030s, we should have a much clearer picture of which moons might be habitable. And even beyond that, plans are already being sketched. Europe's Voyage 2050 concept has picked Saturn's small moon Enceladus as a top target for a future mission. Cassini showed Enceladus has liquid water, chemical energy, and organics, all 3 ingredients for life. No spacecraft has ever landed there, but engineers envision a probe in the 2040s that could sample its icy geysers or even touch down near the plumes. Such a mission would reveal unprecedented secrets of an alien ocean. Meanwhile, astronomers are preparing a revolution in space telescopes. In the 2030s, NASA plans to launch the Habitable Worlds Observatory, a true successor to Hubble and Webb, dedicated to finding life. Sometimes called LUVOIR or HABEX in design studies, HBO will be a massive infrared optical telescope built specifically to image Earth-sized planets. Its goal, to directly capture the faint light of dozens of distant worlds and analyze their atmospheres for life's fingerprints. Scientists estimate it could find roughly 24 Earth-like planets and sniff their skies for oxygen and methane, a combination that screams life. In other words, we may soon have an observatory built solely as an alien life hunter. New ways to listen and look. Of course, probes and telescopes aren't the only game in town. Innovators are inventing radical new ways to listen for aliens. On Earth, we're developing quantum communication networks that send data using entangled particles. Some scientists now ask, what if an entangled particles? Some scientists now ask, what if an advanced civilization has already mastered this and hides its messages in entangled photons? Such quantum signals would fly right past all our normal radio and optical telescopes. In fact, researchers have calculated that an alien quantum internet would be highly secure and therefore invisible to our previous searches. This idea is sometimes called quantum asceti. It suggests we might need entirely new types of detectors and clever algorithms just to know these messages are there. It's like building a fantastic new radio, only to realize the aliens are broadcasting in a completely different dimension we hadn't thought to check. There are other big concepts too. Astronomers also scan the sky for signs of megastructures, the hypothetical Dyson spheres that an advanced civilization might build around a star. Such a structure would have a telltale infrared glow, and surveys of millions of stars have looked for it. So far, none have been found. We also look for strange chemicals in exoplanet atmospheres, industrial pollutants, or gas combinations that shouldn't naturally occur. If we saw a planet with oxygen and chlorofluorocarbons Earth's CFCs coexisting, that would be a smoking gun. In short, wherever life or technology might leave a detectable sign, we are watching. If we find them. All of these missions and methods converge on one monumental question: what will happen if we actually find life or intelligence out there? Most scientists agree the consequences would be huge. Even discovering simple microbes beyond Earth would be a turning point. It would rank among the most profound moments in history, on the order of Copernicus showing Earth is not the center, or Darwin revealing humans are part of nature's tapestry. In fact, astrobiologists say it would prove that life is a cosmic imperative, a natural outcome of chemistry, not a rare accident. Life would go from a solitary phenomenon to a universal reality. We would be forced to accept that Earth is not unique in the tapestry of life. The social and philosophical ripples would be equally vast. Imagine the global headlines the day scientists announce fossil microbes on Mars, or a clear biosignature gas in an exoplanet's atmosphere, or even an unmistakable signal from another star. Governments would mobilize, news networks would break in all languages, and every citizen with a phone or radio would hear it. Religious leaders and philosophers would scramble to interpret what it means for human belief and identity. We have no blueprint for this moment. All our history and culture have been written with the assumption that Earth hosts life alone. That assumption would vanish overnight. Debates would erupt. Are we the children of the stars? How do our worldviews change? Even without direct contact, just knowing life exists elsewhere would reshape us. Many thinkers point out that searching for life is part of our human story. It's about understanding what life means. If life is common in the universe, we will feel kinship with a vast biosphere. If life is extremely rare, we will realize how precious every ecosystem on Earth truly is. In either case, our perception of ourselves would change. We would ask new questions. What is our place in the cosmos? Are we destined to explore forever? Looking back through history, it's clear that expanding our horizons changed civilization. Each great leap, from crossing oceans to walking on the moon, rewrote our sense of place. Discovering aliens would be even bigger. Many compare it to finding an entirely new continent on our map of reality. Our science fiction imagines all kinds of first contacts, but the real moment will be something we've never experienced. In the end, most researchers hope it will be a moment of inspiration and unity, rather than fear and panic. One thing is certain: this adventure is as much about humanity as it is about aliens. We send probes, build telescopes, write algorithms, all to answer questions about our own origins and future. When we stare into the darkness and search for others, we are also asking what it means to be alive. In that sense, Part 2 ends on the edge of tomorrow. The part typer of machines are almost ready. The data are pouring in, and soon, the universe may no longer be silent. And by that light, we will at last see ourselves in a broader, more humbling context, the full story of our search for aliens, Part 3. In the vast, echoing silence of space, humanity stands on the edge of a new era. Our eyes are sharper than ever, and our dreams have never been bigger. Beyond the foundations built by radio telescopes and robotic probes, tomorrow's explorers are preparing instruments and missions that will probe the secrets of distant worlds in unprecedented detail. This is a story of the future, telescopes, and spacecraft on the horizon, the next leaps in SETI, and the profound ways the universe might answer our deepest questions. It is a journey both scientific and spiritual, a tale of technology and the soul, as we brace for the day when we might finally discover that we are not alone. Eyes of tomorrow. Imagine a vast new space telescope, its mirror many times larger than Hubble's, tuned to starlight that has traveled across the galaxy. This is not science fiction, but a real mission concept called the Habitable Worlds Observatory. Scientists are designing it to be the most powerful space eye ever built, a telescope built for the search for life on distant planets. It will be able to directly image other Earths and split their light into rainbows of information, searching for the fingerprints of life, telltale gases like oxygen, methane, and other signs that life might exist there. This dream telescope is a culmination of decades of technology. It borrows ideas from earlier mission concepts and builds on the success of Webb and the Roman Space Telescope. When it flies, Perhaps in the 2040s, it will stare into the habitable zones of the nearest stars and try to find at least 24 Earth-like worlds. Scientists hope to use a coronagraph or a starshade, a giant parasol in space, to block out a star's glare so they can see the faint glow of an alien planet. Every pixel it records, every spectrum it measures, could carry the whisper of life. Even now, engineers and astronomers are fine-tuning the delicate instruments it will carry, ultra-sensitive spectrometers that can sniff out even a tiny trace of oxygen in an alien sky, cameras that can spot a living, breathing world orbiting another sun. These machines of tomorrow will let us chemically analyze distant atmospheres and oceans without ever leaving Earth. Meanwhile, on Earth, new giant telescopes are being built to complement our space observatories. High atop mountain summits, domes of glass and metal, like the extremely large telescope in Chile, will open their eyes to the stars. Their mirrors, dozens of meters wide, will capture faint light from distant planets and send it to advanced spectrographs. These instruments, often calibrated with precision lasers, will break the light into fine detail, measuring the gases of alien atmospheres, methane, water vapor, and perhaps even the fingerprints of biological activity. Together with space telescopes, this arsenal of tools promises to paint a detailed portrait of other worlds. Quest for ocean worlds. While we peer at far-off stars, our explorers are turning to the mysteries in our own backyard as well. Cassini taught us that Saturn's icy moon Enceladus is not a dead rock. It erupts plumes of water and vapor from its frozen south pole. Cassini's instruments sniffed that these geysers carry salty ocean spray and simple organic molecules like methane. And just recently, astronomers reported hydrogen cyanide and other complex organics in those jets, chemicals that on Earth are woven into the very fabric of life. Enceladus has become a beacon of hope in the search for life. Plans are on the table for a future mission called the Enceladus Orbilander, a bold spacecraft that would first spend months orbiting the moon and flying through its plumes, then land on the icy surface to continue the hunt up close. Imagine a probe sampling the air and ice, searching directly for amino acids, or even tiny microbes in the ocean spray. Scientists envision launching such a mission in the late 2030s or 2040s, arriving at Saturn a few years later and landing on the ice by the 2050s when the sun shines on the South Pole. If life's building blocks exist there, this mission might find them. If not, it will tell us why not. Even if resources limit a full-scale landing, a fleet of smaller spacecraft could repeatedly sample those mysterious plumes, pursuing answers bit by bit. Every new sample from Enceladus's ocean could bring us closer to knowing whether life is a rare fluke or a common chapter in the story of the universe, the Martian Promise. Mars is another ocean world, but with its waters locked in the distant past. NASA's Perseverance rover has been meticulously drilling out rock cores in Jezero Crater, the site of an ancient lake that once cradled water and clay. Each metal cylinder it drops is a time capsule from Mars, sealed up to keep its secrets safe. Bringing them home is humanity's most ambitious planetary science goal, the Mars Sample Return Campaign. The plan is breathtaking. Send another spacecraft to Mars to pick up those sample tubes, launch them off the red planet, and ferry them back to Earth. In the original schedule, Mars rocks might arrive around 2033. But our ambitions have hit the harsh reality of budgets and engineering challenges. A review last year forced NASA to press pause and retool the plan, seeking cheaper designs. Still, teams promise not to give up. They know that once those samples arrive in Earth laboratories, scientists will unlock histories that telescopes alone cannot reveal. These rocks could show us whether Mars ever nurtured life, down to the microbial fingerprints. For now, the cylinders remain on Martian soil, each one a promise for future discovery. Listening to the cosmos. While our spacecraft reach for stars, others have trained their ears on the void. SETI, the search for extraterrestrial intelligence, is itself evolving. We no longer just point giant radio dishes at one star and wait. Today, powerful AI algorithms sift through entire sky surveys, hunting for anything unusual. Machine learning systems now analyze mountains of telescope data, flagging patterns that the human eye would easily miss. For example, astronomers at Breakthrough Listen have trained neural networks on billions of signal samples from radio telescopes. These digital scouts can pick out faint anomalies, a narrowband tone or a rhythmic pulse, buried in the cosmic noise. SETI is also embracing the full range of cosmic messengers. We've learned to detect gravitational waves and neutrinos from violent astrophysical events, so we can ask, could a civilization exploit these too? Perhaps a society with a colossal particle accelerator might produce a powerful neutrino beam as a beacon. Or maybe one day someone will propose modulating gravitational waves from orbiting machines. These ideas remain far future speculation, but they remind us to stay open. The universe might send a signal in any form, and we should listen for them all. Finally, astronomers scour the skies for the hallmarks of cosmic engineering. Some have searched for Dyson spheres, vast swarms of solar collectors around stars. A star encased in structures would appear dim and oddly warm. Surveys like G88 Glimpsing Heat from Alien Technologies analyze infrared maps from the WISE Space Telescope, looking for stars radiating excess heat. And we watch the light curves of distant suns for anything peculiar. Tabby's star, with its strange dips in brightness, once sent imaginations racing about alien megastructures. While that mystery seems solved as dust, it taught us to notice the oddest signals. Every time astronomers find a star or galaxy that flickers or glows strangely, they ask, could this be a techno-signature? With each new telescope and survey, our vigilance only grows. The human story. What if tomorrow we wake to find we are not alone? The impact on humanity would be profound. Since the dawn of civilization, people have looked to the heavens and wondered if anyone else is out there. If we finally confirm life beyond Earth, even just microbes on another world, it would rank among history's greatest revelations. Schools would celebrate a new science hero, clumping news outlets would break it around the clock. People everywhere would ask, who are we in the cosmic scheme now? Long-held assumptions would tumble. This would be a Copernican shift of the 21st century, like when we learned Earth orbits the sun, or that humans share ancestors with apes, knowing life arose elsewhere forces a new perspective. We would no longer think of life as a unique gift of Earth. Philosophers and poets would scramble for metaphors. Perhaps the universe becomes a much more crowded, less lonely place. Religion and faith would wrestle with it. History shows that most religions can adapt. Some believers might fear this undermines their teachings. Others would embrace it as part of a divine plan on a larger canvas. Interfaith dialogues have even anticipated these questions. Many religious leaders have already said they could accommodate extraterrestrial life. Yet billions of people might privately question what it means for their souls. We might hear sermons interpreting the discovery in spiritual terms, even as others ponder whether ancient doctrines can stretch to other worlds. In society, reactions would be as varied as people themselves. Social media would explode with excitement, and memes, conspiracy theories, and panic might swirl just as quickly. Remember how rumors flew in other crises? Scientists learned from the COVID pandemic how important clear communication is. Government leaders would likely urge calm, stressing that evidence is still being verified. Community leaders might gather to reassure neighbors, and educators would scramble to explain the science. Some would see this as a moment of unity, the whole world under one sky, while others might respond with fear or skepticism. The emotional tide would not be uniform. Politics and international relations would get tricky. Space treaties declare the cosmos belongs to all humanity, but national pride and fear can complicate things. Countries with powerful telescopes or space programs might vie for credit. In the best case, this could unite Earth's governments around a common goal: to study the discovery and protect our future. In fact, the global SETI community already urges exactly this. They call for an international protocol so that no single country can claim the discovery for itself. Leaders might convene under the United Nations to chart a joint response, reminding us that any finding in space belongs to all people, regardless of borders. Through it all, science would surge ahead. New research centers and missions would immediately get funded. Astrobiology would ignite a renaissance, as scientists scramble to learn how life can flourish in completely different worlds. Children everywhere might dream of distant planets instead of national heroes. The fact that life is not a one-off event would rewrite biology textbooks. Perhaps within a few decades, specialized telescopes and probes would be built solely to study these discoveries. In a very real sense, humanity would finally make the cosmos the next frontier of exploration in earnest. The first contact. The truth is likely to arrive like a whisper, not a fanfare. Perhaps it will come from the steady beeps of a distant telescope or the sterile lights of a lab. Imagine a crisp winter morning when astronomers see something odd. The spectrum of an exoplanet contains a wisp of oxygen and methane together, a combination hard to explain without life. Or picture night falling at a radio observatory and a receiver suddenly lighting up with a series of regular pulses unlike any natural source. In that moment, scientists jolt awake with a realization. They won't rush to the microphones. Instead, there will be caution. Teams will triple-check instruments, call in colleagues at other observatories, scour archives, all to rule out error or earthly interference. They will debate quietly behind closed doors. But eventually, the evidence becomes undeniable. A statement is drafted. Perhaps a global announcement is scheduled. Then the words come, "We have detected evidence of life beyond Earth." The statement will stress caution. Extraordinary claims demand extraordinary evidence. Still, when it arrives, the news will shock and awaken wonder across the globe. Across the world, people hear the news in many ways. On TV screens and phones, as the faces freeze in disbelief and joy. In classrooms, children look up as a teacher whispers the words with awe. Some people bow their heads in prayer. Others stand on balconies, gazing up at the stars in wonder. Regardless of language or creed, a single thought will echo through billions of minds. We are not alone. For the rest of human history, the way we see our place in the universe will have changed. Perhaps it's not a shout of hello, but a quiet proof of life, fossils in a rock, or a coded signal in space. Either way, it would feel like stepping out of a dark theater into daylight. Our entire human story, our books, songs, and science would suddenly have a new chapter. And we would face a profound question: what to do now? Do we try to reach out and respond, or do we just listen and let this sink in? For a moment, the world would stand silent together. The universe has given us an answer. Now, we must decide how humanity will respond. Part 3, Echoes in the Void. The urge to connect. Our eyes lift to the night sky, and something stirs within us. For countless generations, humans have felt an ache at the sight of distant stars. Deep in our hearts is an urge to know whether we share this universe with others. This quest goes beyond science. It is woven into our myths, our longing, our music. We search the cosmos not just for facts or planets, but for kinship among the unknown. For centuries, this yearning has shaped our stories and beliefs. Poets and philosophers, children and scientists alike have found comfort in imagining that we might not be the lone spark of life. The night sky has been our canvas, where we project hopes and companionship. In countless civilizations, from ancient temple murals to starlit campfires, humans have asked, in those distant lights, is someone there asking the same question of us? This longing is visible not just in myth and art, but in the signals we send. For over 100 years, our planet has been broadcasting into the void. Every time we tune a radio or send a television broadcast, an echo escapes into space. In a sense, Earth has become a lighthouse in the cosmic dark, shining the story of our presence outward. Even unintentional signals, radar pulses bouncing off moons, cell phone chatter leaking skyward, form a kind of cosmic call. If an alien were listening, our musical broadcasts and messages would wash over them, an announcement of our existence. On July 16th, 1977, humanity sent a very deliberate message into space. The Voyager 1 spacecraft carried the golden record, a phonograph of Earth's culture meant for any future finders. The record included greetings in dozens of languages, music from Bach to Chuck Berry, and images, a cosmic time capsule of who we are. The golden record itself is a testament to our hope that somewhere, sometime, another traveler might hear our voice. And in quiet moments, we look up at the night sky, perhaps on a warm summer night or a crisp winter eve, Every person who sees the stars above has wondered, at least once, if someone out there sees them back. We do not starve for companionship in all other ways. We build communities on Earth. And yet, for some reason, we hunger for cosmic company too. Perhaps it is because the universe is so vast and our planet so singular in it. When we feel small beneath the stars, we find comfort in the thought that we might not be alone. In every corner of Earth, from city skyscrapers to quiet deserts, people have looked up and wondered if a friend might be watching back. We craft messages in many forms, hoping to say, "We are here, we made it." In our fear of being utterly alone, each new technological advance or star chart is a beacon of hope. For in every advance, we feel the cosmos reaching back to us. The stars have become silent mentors, guiding our dreams. Our search is driven by a mosaic of deep desires, a longing for companionship in the vast expanse of space, a curiosity that questions if our story is unique or echoed elsewhere, an existential hope that life is abundant and not confined to our home, a yearning to belong to a larger cosmic family, however distant. These are not just scientific motivations, they are threads of our shared humanity. In every city, on every continent, children point to constellations and ask if someone else might be there. For many parents, this question is a gift they pass to their children. They point to the night sky and whisper of distant worlds. Educators weave it into lessons and stories. From lullabies about the moon to children's shows about aliens, from ancient star charts to cutting-edge observatories, our question weaves through our collective culture. Each song, each story, and each star chart is a thread in the tapestry of our shared curiosity. For all its technology, this quest is ultimately a human story. It's an echo of our deepest hopes and fears carried across the void on radio waves and in our imaginations. Every radio transmission, every sci-fi novel, every telescope reflects a spark inside us, the spark that makes us wonder, maybe, just maybe, we are not alone. The weight of silence. Yet the more we reach into the darkness, the more it seems to hold its peace. Decades of listening have produced no cosmic voices calling back. We straddle two emotions, wonder at the silence, and a creeping ache at the emptiness. With every new survey of the sky that finds no technosignatures, the silence becomes more pronounced. Each radio dish turns skyward, and each pixel scanned by a telescope returns no answer but our own background noise. And each new world we discover appears cold and dark, at least at first glance. In truth, our silence may not mean nothing is out there. The universe is vast beyond comprehension. We have only been listening for a tiny fraction of its age, and our signals have traveled only a tiny fraction of its breadth. Imagine a person on a distant shore 100 light years away. We shouted a greeting just a century ago, and 100 lifetimes might pass before our hello becomes a whisper there. If civilizations are few and far between, our early attempts may simply be whispers lost in the wind. On the other hand, this seeming emptiness is exactly what made Enrico Fermi ask, in the mid-20th century, "Where is everybody?" He pointed out that with billions of stars older than the sun, the sky should be crowded by now, but it is not. This paradox weighs on the heart. It suggests solemn possibilities. Perhaps intelligent life invariably destroys itself, or maybe it chooses silence. Perhaps we truly were born too early, or, sadly, too late. Some feel this silence with dread. Writers imagine the galaxy as a dark and lonely place where life is an incredibly fragile accident. Maybe the lonely roads of space travel are too hard even for the boldest civilizations. Some thinkers even speculate that the universe might be watching us, or waiting for us to prove ourselves worthy. The silence carries the weight of all these unknowns, but silence also sharpens our ears and steals our hope. Every quiet sky is a challenge to listen better. We remind ourselves that we have barely scratched the surface. New generations of telescopes and arrays will tune to different frequencies, scan new wavelengths. Each null result teaches us something about the conditions for life, even as it makes us yearn for a different outcome. In the quiet, we learn to find meaning in the search itself. We imagine not only what answers might come, but how we would cherish them. Perhaps the silence is just the calm before a great whisper. That paradox The tension between desolation and expectation becomes a crucible for our courage. With each night that passes in silence, our determination only grows stronger. We stand on stage of this vast cosmic amphitheater with just our own voice echoing back, yet we do not despair. If anything, the silence teaches us humility and patience. The universe is not taunting us with its quiet. It is reminding us of how grand a discovery could be if it ever arrives. We train our instruments, we refine our searches, because silence can break at any moment. Maybe the answer will come tomorrow or centuries from now. We cannot say. But every moment we wait is a testament to our hope. The silence is not an enemy, but a blank canvas on which our imagination paints. It is the silence that makes the first signal so precious. For now, the universe keeps its secrets close, and we remain tuned to hear them, hopeful that our patience will one day be rewarded. Searching ourselves. Astronomers like Jill Tarter have said that looking for life out there is really a way of understanding ourselves. Each scan of the sky asks, if there were others out there, how would they see us? The aliens in our stories often reflect our nature. Imagining them as gentle explorers or conquerors reveals our hopes and our fears. The way we conduct the search mirrors our humanity. We look for water and carbon because that is how we define life. And we send images of ourselves because we want anyone out there to know who we are. When we craft an interstellar message, we curate it with our values. The Voyager Golden Record and others like it are attempts to share our story. They carry images of families and nature, diagrams of our DNA, even the sound of a heartbeat. Through them, we broadcast not just data, but the essence of who we are. In each greeting, we encode our aspirations and identity. The act of searching itself reveals our resilience and unity. Decades of silence have not dimmed our will. Rather, they have spurred us to build larger telescopes and refine our methods. We continue listening in more directions, on more frequencies. Each unanswered moment steals our resolve. This persistence, the refusal to give up hope in the face of the void, is a testament to our character. In this quest, we see the best of what humanity can be. Boundless curiosity urging us to explore beyond every horizon. A creative imagination allowing us to dream how others might live. A hopefulness that weaves through our science and story, sustaining us in the void. A spirit of unity as people across the globe collaborate in this shared endeavor. A humility born of unanswered questions, driving us to learn and wonder even more. Each of these is a mirror held up by the stars. As we strive to find new life, we find ourselves reflected back. What stories will we tell about our own existence if an answer finally comes? The journey is already teaching us about ourselves in ways that an answer might not. Even if no alien ever blinks back at us from the dark, we will still have looked at the universe and realized what it means to care. This search is shared by people all over the world. Citizen scientists, amateur astronomers, and students lend their eyes and computers to the cause. Projects like SCT at Home let anyone participate, blurring the line between professional and amateur. The question, are we alone, belongs to everyone, a collective curiosity that spans cultures and generations. Each new mind turned to the sky renews the quest, inheriting the question. Every generation stands on the shoulders of those who gazed upward before. A child today paints galaxies in their notebook, just as an elder once did in the sand. The question of the stars is handed down like a torch. One generation built the first radio telescopes and sent greetings into space. The next generation decoded the faint signals of planets around distant suns. The current generation catalogs thousands of exoplanets in our understanding, each a new chapter in the story. The dream has moved from madcap fantasy to rigorous science, carried by each wave of explorers and thinkers. Frank Drake, Jill Tarter, and countless others started listening with humble equipment, never knowing what they would find. Now, young scientists use computers and quantum sensors to listen in trillions of channels at once. The legacy of wonder has only grown. From the punch cards of the past to the data of tomorrow, the quest persists. In every new telescope and every classroom lesson, the question burns anew. Are we alone? It shapes careers and bedtime stories alike. It inspires a teenager in a small town to study astronomy just as it compelled Galileo to aim his telescope at Jupiter's moons. Across decades, the hunt has taken many forms, but it never fades. Each era of discovery brings fresh dreams. In the 1960s, radio astronomers at newly built observatories began listening, believing for the first time that we might catch a signal from the stars. In the 1990s, the first worlds beyond our solar system were confirmed, igniting the idea that alien planets are everywhere. By the 2020s, space telescopes like Kepler and James Webb began analyzing alien atmospheres for hints of life, turning science fiction into data. Tomorrow, who knows? Perhaps the children born today will uncover the first real answer, or ask the next profound question. Inheriting this wonder means that each generation must also face the uncertainty. The unanswered call of the stars becomes our inheritance. It is both a burden and a gift to know that the question will outlive us, driving us forward and reminding us that, on some level, we are all adventurers gazing up at the same night sky. Each new era adds its own verse to an unending cosmic song. Even if past answers proved elusive, the question always returns. We inherit not only the tools of our predecessors, but their sense of wonder as well. In that sense, it is a gift that each wave of humanity takes up the search anew, carrying the flame forward. Over the centuries, the very shape of the question has shifted with our knowledge. One generation dreamed of Martian canals and cosmic oceans. The next went searching with radios and telescopes. Today, we scan exoplanet atmospheres and send probes to our own neighbors. Each era teaches the next how to ask. The question remains, but the way we pursue it evolves. This continuum of curiosity and innovation is itself our heritage, the journey itself. And perhaps the greatest discovery is that the search itself has become our message. No matter the outcome, we have already journeyed far. We have peered into our galaxy's vastness and cataloged thousands of alien worlds, each one a new chapter in our understanding. We have learned to read the faint signs of atmospheres and oceans from light years away. Along the way, we found new wonders on our own planet, life in the unlikeliest places, teaching us how bold life can be. This pursuit has fundamentally changed the way we see our world, no longer just our tiny home, but a precious oasis in a vast, dark sea. Our quest has given us purpose and perspective. It has united dreamers, scientists, and everyday people across the globe in a shared mission. The unknown compels us beyond our borders and beyond our differences. For out there among the stars, we find a common dream. In searching for life, we have already found meaning. In the thrill of each discovery, the new questions we ask, and the unity it creates. Every null result teaches us to refine our questions and to value what we know more deeply. Even in silence, there is something profound. Perhaps the aliens we seek are not the point. The point is that we looked, that our species dared to listen. In the vast quiet between stars, we hear our own heartbeat. Each telescope dish and radio antenna becomes an instrument tuned not just to distant frequencies, but to our sense of wonder and hope. We stand together at the edge of the unknown, and in that moment of waiting, we learn about ourselves, our courage to face the void, and our solidarity in doing so. Our pursuit has already yielded gifts beyond measure. A sense of scale and perspective. We have come to know how small and precious our planet is in a sea of stars. Unity and collaboration, strangers on Earth become allies when we gaze together at the same sky. Technological leaps, the tools we build to seek the cosmos, often transform life on Earth in the process. Inspiration and hope, our curiosity fuels art, science, and a vision of a future that includes all of humanity. A newfound humility. Each unanswered question reminds us to learn, to stay humble, and to keep our hearts open. This legacy is the true treasure of our search. Even if the night remains still and no answer ever comes back, we have opened our hearts to the universe. We have chosen to be the curious species, the one that looks up with the conviction that even in the darkest void there may be a light. Even as the ages pass, our quest will have made us more compassionate, more united, and more awed by the mystery of existence. So we keep listening. We keep looking up at the stars, together, across generations. And in that continuing search, we find our own humanity, hopeful, brave, and forever reaching toward the unknown. Under the same starlight that watches over us all, our question lives on, and that, perhaps, is the greatest discovery of all. Through this search, our perspective on Earth has been transformed. We now carry a keen awareness of our planet's fragility. If Earth is the only cradle of life in a silent cosmos, then every creature here becomes all the more precious. Knowing that our world might be unique for eons gives us a sense of responsibility to ourselves, each other, and the generations ahead. In seeking life elsewhere, we have rediscovered what it means to care for life here. In philosophical terms, the quest illustrates that sometimes the journey is as meaningful as the destination. Some thinkers say that even if we never find other life, we will have already learned the most important lesson: how to remain hopeful and curious in the face of uncertainty. By daring to look up and ask, we have shown that we value exploration above answers. That insight, that the search shapes us, may be our greatest legacy. Whether or not the cosmos ever responds, our collective story is richer for having undertaken this adventure. Each discovery, each unanswered question has become a chapter in the saga of humanity. The full story of our search for aliens. Part 3, Celestial Reflections. Across generations, from the first stargazers to today's scientists, a single thread connects us all: the hope that somewhere out there, we are not alone. Even without a signal or a sign, the search itself binds us together across time and space. Each generation listens to the whispers in the stars, carrying forward the same questions and the same wonder. Grandparents who once pointed excitedly at the night sky share that wonder with grandchildren watching the same stars. Families huddle by radios with glowing dials, listening for a cosmic hello. Every new child born with eyes turned upward inherits the legacy of the dreamers before them. Searching for life beyond Earth has become a rite of passage, a story we pass from one generation to the next. It is a candle lit by our ancestors, burning still at the edge of the universe. Even without proof, the quest itself is proof of something deeper: our enduring curiosity and our fearless desire to understand the universe and our place within it. When we look outward, the way we see ourselves on Earth changes. The more we scan the skies, the more we recognize the fragile unity of the tiny world beneath our feet. From some distant vantage, Earth would appear as a pale blue dot, a delicate orb of life suspended in a great cosmic dark. That perspective is real, and it reverberates through every mind that gazes at the stars. It humbles us and makes us see our home in a new light. In that cosmic mirror, our differences fade. All the wars, the borders, the creeds that once seemed so defining become faint echoes against the immensity of space. Scientists, poets, and dreamers alike feel a shared awe. Every joy and every sorrow humanity has ever known unfolded on that tiny speck of light. When we listen for a greeting from another world, we are also crafting a message to ourselves. We are one family, living together on the only home we've ever known. Reaching into the void carries a weight beyond the scientific. It has become something like a spiritual journey, a modern pilgrimage for our species. In every message we send, in every telescope we turn toward the sky, there is hope and longing. This is more than radio waves or robotic probes. It is an attempt to touch the infinite, to whisper in the language of the stars, and to invite them to listen. Even a child on a quiet night with a homemade telescope feels this connection. Perhaps long ago, someone just like them looked at the same patch of sky, wondering the same questions. The search is a circle of generations, each linked hand in hand, each drawing breath from the same source of wonder. Even if the stars remain silent, that silence becomes part of the story. It teaches us patience, humility, and keeps alive the spark of belief that something incredible might be just beyond our reach. What does it mean that we, a species of stardust, are the ones searching? It means curiosity runs in our veins and courage lights our way. We have the audacity to ask who else is out there, and the bravery to sit with the silence when no answer comes in. Seeking other life, we rediscover the best of ourselves on Earth. We become caretakers of our home, even as we dream of new worlds. Each quiet night, every missed signal draws us closer to our neighbors, to our own planet, to hope. In the end, the search for aliens has become a mirror reflecting our own humanity. It reminds us of unity, of hope, and of the endless wonder that fuels our journey. We are the children of Earth, gazing at the night sky, yearning and waiting. Our story has no final chapter yet, but the lines we've written so far are full of compassion and connection. Now, as one chapter closes, we take a deep breath, carrying with us the warmth of everyone who dreamed before us across every culture, across every era. People have tilted their faces toward the night and asked big questions. Ancient storytellers imagined others watching our skies just as we watch theirs. Every generation has looked up in wonder, seeking meaning in the stars. The search for the unknown is written into our collective story, from the cave paintings of long ago to the observatories of today. It reminds us that no matter where we come from, we share the same sky and the same dreams. The search itself has become a kind of time machine, linking past and future. We tune radios and launch rockets with hands our grandparents never held, yet in doing so we honor a curious spark that they knew too. The golden records we send into space are messages in bottles cast into a cosmic ocean meant for whoever might find them, and also for us. They remind us that we are part of a lineage of dreamers reaching across the ages. And if the universe remains silent, even that silence speaks. It says that we have a task here on this pale blue dot, and it is ours alone. Perhaps the greatest message in this search is that life is precious and fragile and worth protecting. As we wonder about alien skies, we learn to cherish our own. Each search brings us closer to one another on Earth, united by a story of hope, curiosity, and shared destiny. As we turn the page on this chapter, our eyes already lift toward tomorrow. Beyond the quest for a signal lies a new horizon, humanity's future among the stars. Part 4. The next chapter. Our future among the stars. The next pages of our story move beyond listening. We stand at the dawn of a new era, where searching will be only the first step. Rockets once pointed at distant worlds will soon land upon them. We imagine cities under alien skies, spaceships on empty moons, and the human spirit flourishing in light years of new terrain. This is our moment to leave the nest, to carry not just our questions out into space, but ourselves as well. What happens if we do find life? Even a glimmer of another living thing, from simple microbes to something more complex, would reshape our plans. We would become guests on a world that already has its own story. Perhaps we would step carefully, focusing on study rather than conquest, knowledge rather than exploitation. Finding life could unite humanity under a new purpose, to protect this discovery, and to learn how we fit into a larger cosmic community. And what if the silence persists? If every planet we visit remains lifeless, then those barren worlds become our new horizons. They will be silent canvases waiting for life to take root. Some dream of terraforming them, seeding life where none exists. Others caution that even empty worlds deserve respect and careful study. In either case, our approach to expansion will be guided by what we have found or not found among the stars. For example, the talk of building cities on Mars or camps on Titan already fills our imagination. Yet even as we plan to plant human flags, we must ask what marks we leave behind. If we discover even a single microbe in a Martian soil sample, what then? Would we become gardeners of a new Eden, or humble observers of a fledgling world? And if Mars and the moons turn out to be completely sterile, will we feel free to shape them as we please, or compelled to proceed with reverence for their quiet? Our young explorers will have to answer these questions on behalf of all humanity. Ethical decisions are being made today in meeting rooms and mission statements about what we may or may not do on other worlds. Some scientists argue that finding alien life would be a gift to be preserved at all costs. Others warn that we have a duty to spread life if it has no other home. It is a profound choice. Are we caretakers or conquerors? Every spacecraft we send, every person who steps onto a foreign world, will carry that question with them. In the silence between the stars, our conscience speaks as loudly as our technology. Looking ahead, humanity's role in the galaxy remains open. If we stay true to our best selves, we may become caretakers of life itself, nurturing ecosystems across many worlds. Perhaps one day we will join a community of other civilizations, exchanging knowledge among the stars. The very act of reaching out has already made us part of a grand cosmic story. Whatever awaits, we will face it with curiosity, courage, and compassion. The stars await our next step. Humanity stands at a unique intersection in the timeline of the universe. A species that has only recently opened its eyes to the cosmic ocean, yet dares to imagine crossing it. The galaxies around us are not merely distant islands of stars. They are chapters of possibility, waiting for a civilization bold enough to read them. And while the universe appears vast, cold, and indifferent, it is also filled with pathways, natural structures, and cosmic phenomena that could determine whether intelligent life survives or disappears like a spark in an endless night. To understand our future, we must first comprehend the architecture of survival woven into the universe itself. For every threat the cosmos presents, it also provides a counterbalance, a subtle mechanism that allows complexity to endure. Civilizations capable of recognizing these mechanisms may extend their existence beyond the fragile lifespan of a planet, a star, or even a galaxy. Interstellar migration, the silent invitation of the stars. Each star is not merely a fusion engine burning through its life, it is a temporary sanctuary for matter to organize itself into complexity. The energy it provides, the gravitational stability, the formation of habitable zones. All these conditions exist only for a brief cosmic moment. For Earth and the Sun, that moment spans roughly 10 billion years. We arrived late into the timeline of our star, with less than half of its habitable lifespan remaining. But the galaxy is not static. Over millions of years, stars drift, spiral, and redistribute themselves. They pass near one another, forming temporary gateways, opportunities for civilizations to migrate without needing impossible technological leaps. A star passing even a few light years from another can reduce the required energy for interstellar travel by orders of magnitude. Most species, if they exist, might wait for such alignments, not because they lack intelligence, but because the universe rewards patience as much as ingenuity. Perhaps the reason we observe no galactic empires is not the absence of life, but the absence of urgency. Civilizations that survive may not be conquerors, but long-term strategists shaped by the rhythm of cosmic time, the great stellar engines. For species unwilling to wait, the universe offers other tools, but only to those who can harness the full power of stars. Shkadov thrusters. Imagine a civilization building a megastructure partially surrounding its star, reflecting a fraction of the stellar light in one direction. Over thousands of years, this imbalance in radiation pressure would act like a solar engine, accelerating the entire star, planets, and all, across the galaxy. This is not science fiction. It is a mathematically sound concept, requiring only mastery of materials and engineering far beyond our current reach, but not beyond physical law. A species capable of controlling the motion of stars would not wander through the cosmos. It would shape its own trajectory through it. Stellar recycling. Stars are mortal. But advanced civilizations may discover methods to extend their lives, slow their nuclear fusion, or even stimulate controlled mass transfer between binary stars. The universe grants long-lived red dwarfs trillions of years of stability. Perhaps future humanity will seek such stars as long-term refuges. In this sense, intelligent life becomes a gardener of light, tending to the embers of stars to prolong its existence. Cosmic threats and the intelligence test. Humanity evolved on a world shielded by its magnetic field, enriched by geological activity, protected by the gas giants that deflect comets, and placed at a safe distance from supernova rates. But the galaxy has regions far less forgiving. Any civilization that reaches a technological adolescence inevitably confronts a series of challenges, not metaphysical tests, but physical ones, that determine its ability to endure. Gamma ray bursts. A single gamma ray burst could sterilize planets across thousands of light years. Life must be fortunate enough to arise in a cosmic neighborhood where such events are rare. The regions near the galactic core, with high star formation and frequent stellar deaths, may be barren, not because life never arises, but because it cannot persist. This implies something profound. Advanced life may only emerge in the outskirts of galaxies, the quiet, dim regions where catastrophes are infrequent. Supernovae. Even supernovae pose a threat to life within 50 light years. Yet they also seed galaxies with the metals necessary for planets and organic chemistry. Too few and no complexity arises. Too many and none survives long enough to evolve. Intelligence is not merely a biological puzzle. It is the delicate outcome of cosmic circumstances that strike a nearly impossible balance. Planetary extinction cycles. Mass extinctions on Earth have repeatedly reset the evolutionary clock. Without them, mammals might never have risen, and humans certainly would not exist. But each extinction is also a reminder. Life on any planet walks a tightrope stretched across billions of years. Civilizations that endure must eventually transcend their homeworlds. Not because they seek expansion, but because survival demands it. The horizon of civilizational growth. If intelligent life does survive its cosmic adolescence, what comes next? The steps between a young technological society and a multistellar civilization are enormous, but they are not infinite. There are recognizable stages, markers of progress, that any species might follow. Type I civilizations, masters of a planet. A Type I civilization harnesses all energy available on its homeworld. It stabilizes climate, shields itself from asteroid impacts, and eliminates existential risks emerging from its own planet. Humanity is at roughly 0.73 on this scale. The leap to Type I may be our greatest trial. Type 2C, masters of a star. A Type 2C civilization captures the full energy output of its star. Dyson spheres, Dyson swarms, and stellar collectors become practical engineering. At this level, extinction is no longer tied to a single world. Type the Third, masters of a galaxy. A Type the Third species does not travel from star to star. It spreads information, automation, and self-replicating systems capable of expanding faster than organic life. It may no longer exist in biological form. Such a civilization would be nearly invisible unless it intended otherwise. Perhaps the silence we observe is not emptiness but discretion, humanity's potential path. The most astonishing realization is that there is nothing in the laws of physics preventing humanity from reaching any of these stages. The universe does not forbid it. The obstacles are not cosmic. They are psychological, social, and biological. Perhaps we are alone not because others failed, but because intelligence always emerges on the knife's edge of self-destruction. If we pass through this narrow window, the universe ahead is vast and open. The future is not predetermined. It exists as a branching set of possibilities, and each generation narrows or expands that branching structure. Humanity today is choosing not only its fate, but the fate of whatever intelligence the universe may ultimately contain. The anatomy of a cosmic civilization. If humanity ever becomes a long-lived species, a true civilization capable of surviving cosmic timescales, it must first understand what defines longevity in the universe. Stars perish, galaxies collide, planets wither. But the universe itself continues, expanding and cooling, with structures evolving slowly across billions of years. Any species that endures must learn to adapt not just to a planet, but to an entire universe that never stops changing. Survival, therefore, may not depend on technology alone. It may depend on philosophy, cooperation, and the ability to see beyond the instincts we inherited from our Paleolithic ancestors. The cosmos rewards species capable of stepping outside the narrow boundaries of tribal thinking and embracing the long view, a perspective measured not in years, but in epochs. The core traits of survival. Across evolutionary history, species that thrive share certain characteristics. In the cosmic context, these traits become even more essential. If intelligent civilizations exist elsewhere, they likely converged on similar principles, not because they share our biology, but because physics itself shapes these necessities. 1. Stability over aggression. On Earth, competition drives evolution. But in a technological civilization, unchecked aggression becomes self-destructive. The power to shape worlds, split atoms, or engineer pathogens requires a shift from instinct to reason. Any species that fails to adapt its psychology will not survive long enough to reach the stars. Thus, long-lived civilizations may be inherently peaceful, not out of morality, but out of necessity. 2. Patience as a fundamental resource. The cosmos unfolds slowly. Stars form over millions of years. Galactic structures shift over tens of millions. The opportunities for interstellar travel, star passes, nebula convection streams, gravitational alignments happen on timescales far longer than any human civilization has existed. Patience, therefore, becomes as essential as energy. A species that can think in terms of millennia instead of decades will fare better in navigating galactic pathways, selecting migration windows, and planning long-term survival strategies. 3. Mastery of energy, not territory. Territory is a concept inherited from our animal past. But in the universe, territory is nearly meaningless. Stars are separated by light years of empty space. What matters is energy. Every step up the ladder of cosmic civilization corresponds to the ability to harness more of it. Planetary energy, type I, stellar energy, type the third, galactic energy, type the third. A species fixated on borders cannot survive in a universe where energy, not land, determines survival. 4. Curiosity as a lifeline. Curiosity isn't a luxury, it's survival. Without the desire to understand the cosmos, a species remains vulnerable to the very universe it inhabits. Astronomy warns of dangers. Physics reveals pathways. Biology expands possibilities. Curiosity ensures adaptability, the single most reliable predictor of long-term survival. The cosmic isolation filter. If intelligent life is common, why don't we see it? One possibility is the isolation filter, the idea that civilizations intentionally avoid revealing themselves. Why? Because the universe is dangerous. A signal broadcast across interstellar space could reveal a civilization's location to unknown others. In a universe where extinction is always possible, discretion becomes the default. Thus, advanced civilizations might mask their energy signatures, avoid constructing visible megastructures, use highly directed, encrypted communication, remain silent to avoid unnecessary risks. Humanity may seem loud now, with our radio emissions leaking into space, but these signals dissipate rapidly. As our technology advances, we naturally become quieter, using fiber optics, tight beam transmissions, and digital networks. Ironically, a mature civilization becomes invisible long before it becomes interstellar, the blueprint for humanity's future. So what must humanity do if it hopes to transcend the vulnerabilities of a planetary species? The path is clearer than we think, and it mirrors the probable path of countless civilizations across the cosmos. Step 1, achieve planetary unity, not in the sense of a single government, but in the sense of shared existential purpose. If humanity recognizes that its survival is tied to cooperation, not conflict, the resources of the planet can be redirected toward long-term goals rather than short-term disputes. Step 2, secure the homeworld. Before we can look outward, we must remove existential threats, asteroid impacts, engineered pandemics, climate destabilization, technological collapse. A safe planet becomes the foundation for expansion. Step 3, establish off-world habitats. The Moon, Mars, and orbital habitats act as life insurance. Even small colonies exponentially increase our survival probability. Step 4, industrialize space. Asteroid mining, solar collectors, and autonomous construction systems minimize the need for planetary resources and allow exponential technological growth. Step 5, expand to nearby stars, rogue probes, sleeper ships, rotating habitats. The exact method is less important than the fact that we must eventually leave the cradle. Step 6, transform philosophy. Perhaps the most difficult step. Humanity must evolve its thinking from tribal, short-term survival toward cosmic-scale reasoning. Civilizations that fail at this step do not perish through malice, they perish through stagnation, the silence between stars. As we contemplate the nature of cosmic civilizations, one question grows louder. Where is everyone? The silence is frightening, not because it implies we are alone, but because it implies that the universe may be filled with civilizations that chose, or were forced, to remain silent. Or perhaps we are simply too early. The universe is only 13.8 billion years old. The majority of habitable planets around long-lived stars, red dwarfs, have trillions of years ahead. That means humanity may be part of the first generation of intelligent life in the cosmos. If so, our actions matter enormously. We may not just be one civilization among many, we may be one of the first voices to appear in the cosmic dark. When the universe begins to listen, if humanity is among the first intelligent voices to emerge in the cosmos, then the silence we observe is not an absence. It is a prelude, a pause before something begins. The universe, vast and ancient, may still be in its early chapters of conscious life. And in those chapters, intelligence is fragile, rare, and easily erased. From this perspective, the search for extraterrestrial life is not only about finding others. It is about understanding ourselves, our chances, our dangers, and our responsibilities. The fragility of awareness. Life can be resilient. Bacteria survive in ice, radiation, and vacuum, but intelligence is delicate. It requires stability, time, and an uninterrupted chain of complexity stretching across billions of years. A single planetary catastrophe can erase hundreds of millions of years of evolutionary progress in an instant. This means that the universe may be filled with failed attempts, worlds where life began but never reached awareness, or reached it briefly before being extinguished. Civilizations might rise like sparks, only to vanish before their signals ever cross interstellar space. From afar, such a universe would appear silent, not because it is empty, but because intelligence rarely lasts long enough to be noticed. The narrow window of communication. Even if civilizations do exist, their overlap in time may be vanishingly small. On Earth, technological civilization has existed for less than 1% of the planet's history. Our radio signals have traveled barely 100 light years, a tiny bubble in a galaxy 100,000 light years across. If another civilization arose 1 million years ago and collapsed 1 million years ago, we would never know it existed. Their cities would erode. Their satellites would decay. Their signals would fade into cosmic noise. Civilizations do not need to be rare to be invisible. They only need to be brief. The universe as a filtered archive. The cosmos does not preserve history easily. Stars recycle matter. Planets melt and reform. Galaxies collide and erase their past. Unlike Earth, which keeps fossils and geological records, the universe is an efficient eraser of evidence. This creates a chilling possibility. The universe may have hosted many intelligent species and erased nearly all traces of them. What we observe today may not reflect what once existed. In that sense, astronomy is not only a search, it is an archaeological effort on a cosmic scale, one made infinitely harder by time. The first true test of intelligence. Many assume that intelligence is measured by technological advancement. But from a cosmic perspective, the true test may be something else entirely. It may be the ability to restrain power. Every civilization that reaches a certain threshold gains the ability to destroy itself, intentionally or accidentally. Nuclear weapons, engineered pandemics, uncontrolled artificial intelligence, ecological collapse. These are not uniquely human dangers. They are the natural consequences of intelligence manipulating reality faster than wisdom evolves. Civilizations that survive may not be those that advance the fastest, but those that learn when not to act. Restraint may be the rarest cosmic trait of all. Why we might never meet them. As humanity imagines contact with extraterrestrial intelligence, we often picture dramatic encounters, signals, ships, or messages from the stars. But the reality may be far quieter. Advanced civilizations may exist in forms we cannot easily recognize, distributed across machines rather than bodies, embedded in environments rather than cities, operating on timescales far slower than human perception. Communicating through physics we do not yet understand. They may not wish to be found. Or they may not recognize us as something worth contacting, not yet. A civilization that has survived for millions of years may view a species that has barely left its planet as an unfinished thought rather than a peer. The question beneath the question. When we ask, are we alone? We are often asking something deeper. Are we meaningful? Are we temporary? Are we destined to vanish without a trace? The fear of cosmic loneliness is not about aliens. It is about impermanence. The universe does not promise survival. It does not reward intention. It simply allows possibilities and eliminates most of them. Yet here we are. Against overwhelming odds, consciousness emerged. Matter learned to observe itself. The universe developed eyes. Humanity as a turning point. If humanity survives long enough, we may become something unprecedented, a species that carries awareness beyond a single planet. In doing so, we would transform intelligence from a local accident into a persistent cosmic phenomenon. At that point, the universe would no longer be silent, not because others finally spoke, but because we did. The first voice does not hear echoes, it creates them, listening into the dark. Today, our instruments listen carefully. Radio telescopes scan the sky. Space observatories analyze atmospheres of distant worlds. Robotic probes explore icy moons and ancient rocks. Each signal we search for carries a quiet hope, not just of finding life, but of finding continuity. Proof that intelligence can last. That awareness is not a fleeting anomaly. And if we find nothing, then the responsibility is even greater. Because in a silent universe, every intelligent species becomes a seed. And seeds must choose whether they will wither or spread. The meaning of the search. The search for aliens is not a distraction from life on Earth. It is a mirror held up to our future. It asks us, how long can we last? What kind of intelligence do we want to be? Will we become caretakers of life or its final witnesses? The universe does not answer these questions. We must.